Okay friends, today our point to understand about the bonding in alkyne compound. The first member of alkyne series is ethine. Its commercial name is acetylene. Its molecular formula is C2H2 and structural formula H single bond C, triple bond C, single bond H. In structure of ethane, there are two carbon atoms, C1 and C2. There is a triple bond between both carbon atom and both carbon atoms are attached with single hydrogen through a single bond, sigma type bond. Now you see, if you want to determine the type of hybridization in carbon, C1, now you calculate the total number of sigma bond remain around the carbon atom. In case of C1, 1 and plus 1, 2. This carbon is surrounded by 2 sigma bond, that's why C1 में hybridization sp होगा. Similarly, C2 is also surrounded by 2 sigma bonds. तो C2 में भी hybridization sp ही होगा. Now, first of all, we'll take ये C1 ले लेंगे. As per electronic configuration of C1 in ground state position, 1s2, 2s2, 2px1, 2py1 and 2pz is vacant. After giving some energy to ground state carbon atom, yes, change always observe in outermost orbit. outermost orbit में 2s में से 1 electron will transfer from to vacant 2pz orbital. Finally, outermost orbit में 4 unpaired electron हो जाएंगे. Now, as per our calculation, both C1 and C2 sp hybridized. What is the definition of sp hybridization? The hybridization in which one s type and one p type orbitals will participate. In this case, one s2s orbital and one p type 2px orbital. You see the plane. This is the sp hybridization. Here, both 2py and 2pz orbitals will not participate during the hybridization. They will remain as it is. Here, 2s and 2px, they will mix up to each other and forms a equivalent set of hybrid orbitals. How many orbitals participate during the hybridization, Swara? 2. Then 2 hybrid orbitals will also form, and these hybrid orbitals are known as the sp hybrid orbitals. These 2 sp hybrid orbitals possess same shape, same energy, same size, but the energy of these sp hybrid orbitals will be more than 2s orbital and less than 2p orbital. Okay, तो उसको हम बीच में इंडिकेट करेंगे. The orbitals which have not participated during the hybridization, they will show as it is 2py and 2pz. These both orbitals possess one unpaired electron. Same way, to hybrid orbitals, 2 sp hybrid orbitals will also possess one unpaired electron. Now see, in C2, case of C2 is also sp hybridized. तो डायरेक्ट लिख दे C1. This one is sp hybridized C1, sp hybridized C2. So here two hybrid orbitals will arrange in a three-dimensional space in such a way that the repulsion formed between each orbitals will becomes minimized. It is only and only possible when they will arrange at 180 degree, otherwise you can say linear state. यहाँ टू हाइब्रिड ऑर्बिटल्स है, 360 एंगल को 2 से डिवाइड करो तो 180 आएगा. तो यहाँ ये C1 is C2. 2py and 2pz will remain as it is. Now see, C1 and C2 के बीच एक सिग्मा बॉन्ड है. One sp hybrid orbital of C1 will overlap one sp orbital of C2 and form a sigma bond. This is sp of C1, sp of C2. ये सिग्मा बॉन्ड फॉर्म होगा. अब दोनों कार्बन की एक एक sp hybrid orbitals बाकी है. तो the remaining sp hybrid orbital will overlap with 1s orbital of hydrogen. यहाँ भी ऐसा ही होगा. This is the sp hybrid orbital of C1 will overlap with 1s orbital of hydrogen and form sigma bond. Same way, here also sigma bond formation you can explain. One more thing. The orbitals which have not participated during the hybridization, they always responsible for pi bond formation. So यहाँ 2py and 2pz both orbital have not participated. That's why this both orbitals are responsible for pi bond formation. 2py both 2py orbital of both carbon atom will overlap, yes, parallel, then form a one sigma bond. This is 2py orbital of C1 and this is 2py orbital of C2 and form a one pi bond. Second pi bond will form by 2pz. This is the 2pz orbital. This is also 2pz orbital of C2. They will also overlap parallel. After parallel overlapping, they will also form the second pi bond. This is the 2pz orbital of C1. This is 2pz orbital of C2. It will also form a second pi bond. तो यहाँ इस कंपाउंड का टाइप क्या है? अल्काइन. Alkyne compound, the hydrocarbon compound in which minimum one triple bond is present between two carbon atoms is known as alkyne compound. ये alkyne series का member है. Hybridization sp, then angle will be 180. The shape, you can say symmetry also, will be linear. Number of bonds. Now you calculate number of bonds. 3, 4 and 5. Among the 5 bonds, 3 sigma bonds are there and 2 pi bonds are there. 1 CC sigma bond, this one. Then 2 CC, दो कार्बन के बीच pi bond है. ये 1 plus 1, 2. Then 2C single bond H type. This is also sigma type bond. ये 1 और ये 2. One more thing. Finally, strength and length. Bond strength and bond length of both CH bond is same. Why? ये दोनों बॉन्ड फॉर्मेशन के लिए कार्बन की sp ऑर्बिटल्स और हाइड्रोजन की 1s ऑर्बिटल रिस्पॉन्सिबल है। वो फ्रॉम वन साइड sp ऑर्बिटल having same energy, other side 1s orbital of both hydrogen atom possesses same energy। तो यहाँ जो बॉन्ड बनेगा उसकी लेंथ भी इक्वल होगी, इसकी स्ट्रेंथ भी इक्वल होगी। तो यहाँ दिस इज द एक्सप्लेनेशन ऑफ बॉन्ड फॉर्मेशन इन इथाइन, अदरवाइज यू कैन से अल्काइन कंपाउंड। ये फिगर भी जरूरी है, एक्सप्लेनेशन भी जरूरी है। फाइनली ये THASNS ये सब पॉइंट इंडिकेट करना। ओके, थैंक यू वेरी मच। हम नेक्स्ट लेक्चर में आगे चलेंगे।